You will see us playing in summer with friends at home or even on the beach or at cafes. In winter if we stay home to have more fun, or even the elder people at coffee shops playing all day. You will see us playing anytime and anywhere. You will see people getting mad because they lose, but anytime in the friendly, warm and beautiful surrounding of people we love to be with our favorite people, with people who love us. You may have seen tournaments of this sport. To win the tournament, people play with passion. People from all countries contest each other. But to be honest, behind all this, the main purpose is to fun. But we are talking time for what? We are talking, of course, about maybe our Greeks' national game, backgammon. Anyone has a backgammon board at home. But before we continue, we would like to tell some things about it, for which even we didn't know before. According to Wikipedia, backgammon is one of the oldest board games for two players. The playing pieces are moved according to the roll of dice, and players win by removing all of their pieces from the board. There are many variants of backgammon. Despite the fact that luck is actively involved while playing, strategy plays an important role for the sequence of the game. With each roll of the dice, players must choose from a numerous options for moving their own checkers and anticipate possible counter moves by their opponent. Each player has his own tactic, and that's the reason for having excellent backgammon players. Different characters, knowledge, ages, experience, different gameplay. Backgammon, in the same way like chess, has been studied with great interest by computer scientists. There is a huge research behind these games, which gives the ability to computers to compete anyone, with a positive possibility of winning. Owing to this research, backgammon software has been developed capable of beating world-class human players. According to Wikipedia, artificial intelligence is the intelligence of machines, and the branch of computer science that aims to create it. John McCarthy, who coined the term in 1956, defines it as the science and the engineering of making intelligent machines. Nominated actor Keira Knightley, who is famous as a protagonist in Pirates of the Caribbean, is a fan of the game. Backgammon is a really old game, which we not knowing its real origin or its age. It is found that a similar game existed in Iran at 3000 years before Christ. It is also played since the ancient years in many countries and towns, and appear widely in paintings. Some of these we are watching them now. Backgammon is maybe our national board game. It's a very popular game among Greeks in all countries including Cyprus. It is played by young and old people in coffee shops. While playing the game, Greeks usually tease their opponent and a lively atmosphere is created. It has the name tavli, which means board in Greek. The most common variations of tavli in Greece are portes, plakoto and fevga. These games are played one after another, usually in matches of 3, 5 or 7 points. The game is conducted in a board containing 24 points divided in 4 quadrants of 6 points each. Each player starts the game with its checkers placed in fixed starting positions like here. The players take turns playing their checkers using an element of chance in the form of two 6-sided dice. According to the game rules, when all the checkers of a player are inside his last quadrant of the board, the so-called home board, he can start removing them. The player that removes all his checkers first is the winner of the game. There are tactics a player can follow in order to win. Many times before to play a role, the player measures their own position in the game. The minimum total of dice rolls needed to move a player's checkers around and off the board is called the pip count. The difference between the two players' pips count is frequently used as a measure of the leader's racing advantage. Players often use some mental calculation techniques to determine pip counts in live play. Artificial intelligence in backgammon. Backgammon software is created for many reasons and is really impressive. First, it can be used to play with a person or analyze games. It can also be used to facilitate between humans over the internet. Backgammon has been studied in depth by computer scientists. They use techniques like neural networks and other approaches which offer rich advances to software for game analysis and gameplay. BKNG 9.8 was the first strong computer opponent. Hans Berniller wrote the code in the late 70s as an experiment in evaluating board game positions. After many improvements, BKNG 9.8 was very strong in gameplay. It could play very well against the king of backgammon of that period and world champion Loizou. Not only he played with the championship, but he also defeated him. More precisely, it won the match with score 7-1, and the program became the first computer program to defeat a world champion in any board game. After the victory, Berliner stated that the computer's win was in a great degree a matter of luck, as the program received better dice rolls than the championship. A decade later, computer scientists who worked in this field used an approach based on artificial neural networks and found more success. Gerald Tesauro of IBM has developed Gammon. Gammon was the first of these programs to play near the expert level and the level of the top human players. The neural network of the application was trained using temporal difference learning applied to data generated from self-play. In the latest years, the efforts of neural network research gave birth to 5 modern programs. We are talking about Snowy, Jellyfish, and the Extreme Gammon, 3 proprietary programs, the shareware program Binging Bliss, and the famous free software GNU Backgammon. Using these programs, you can have not only a great game, but you can also analyze your game and take a detailed comparison of individual move too. The above programs are very strong. Their strength lays in their neural networks weights tables and at the huge time of training. The tables and their excellent training are the key to their success. For the BRF phase, the software usually uses a database which contains pre-computed quantities for all possible BRF positions. We will now explain the basic ideas behind the algorithms these programs use. We will start with reinforcement learning, a technique which takes place in backgammon algorithms is reinforcement learning. Algorithms learn a policy that maximizes the agent's long-term return from the performance of a task. It explores through all possible and different situations. When it reaches the target, for example a win, it takes a reward. The reward can be positive or negative. If it's negative, the move was probably wrong and the algorithm learns from its mistakes, so the next time will be better. It's analogous to the child's behavior example. If he makes some things wrong, he gets some kind of punishment, like being in his room for 2 hours. If he makes something good, he takes a reward, like a walk at the zoo. Reinforcement learning is used in problems where it is not easy to teach an evaluation function from examples for each situation. It is also used in problems where it is not easy to find general good rules. Here we have an example of reward. If the programs find a solution which wins, it takes 100 points. If it loses 100 points. For all other states, it takes 0 points. Temporal inference learning is a prediction method. It has been mostly used for solving the reinforcement learning problem. TND learning is a combination of Monte Carlo ideas and dynamic programming ideas. TND resembles a Monte Carlo method because it learns by sampling the environment according to some policy. TND is related to dynamic programming techniques because it approximates its current estimate based on previously learned estimates. Minimax algorithm. Given a situation, it tries to decide the next move against the opponent. It is not possible to search the whole search tree. It is wanted the tree to be built until some height and to find the best move while being at the current situation. In order to find which situation is better than other, you have to use an evaluation function, which is applied at the leaves of the tree. The first player is called max and the second min. Here we can see the minimax pseudocode. Apply the evaluation function to all the tree leaves. While there is a node of the tree which has not a value, repeat. Starting from the leaves of the tree and towards the roots of the tree, transfer the values to the intermediate vertices as follows. The value of each node max is the maximum value of the node's children. The value of each node min is the minimum value of the node's children. The best movement is the movement that leads to the node that has the most advantageous price to the root, the maximum for max and the minimum for min. Here we can see an example of minimax algorithm. We have a tree at this height. We have evaluated every possible instance and their values are at the leaves of the tree. Then we are going from the bottom to the root. We find the minimum values, then the maximum values, then the minimum values again, and then the maximum value again. So we will move to the left of the tree. Neural networks. Artificial neural network is inspired by the structure of biological neural network and is used in artificial intelligence. A neural network consists of an interconnected group of artificial neurons. It has always an input layer of neurons and produces an output at the output layer of neurons. There are hidden levels of neurons. A neuron at each level is connected with every neuron at the previous level. Each neuron is a function which takes as input the weighted sum of the output of the previous level. Each line has a weight. These weights define how important is each result of a neuron as an input at each neuron at the next level. We have to train the network before we use it. By this, we mean that we have a set of training data, for example previous backgammon games, and their expected output. We pass as an input this data at the neural network. Each time the neural network makes a mistake, we say to the network that it has done a mistake. Then the network automatically adjusts all the weights of the edges of the network. Because of that, the network learns by itself and continuously improves itself. It simulates the way of human thinking and brain. We stop training when the differences of weights are tiny or when we believe that our algorithm has pretty good results, or after some number of times we tried. Modeling an instance in Backgammon. We said that each neural network takes an input and produces an output, so each instance of the game has to be modeled in order to be inserted in a neutral network. For example, an instance can be modeled like this. Darwin's experiment board representation. Representation has 122 inputs. How many pieces are of the board? How many pieces are on the bar? For each of the board's 24 positions, we want one input to indicate if the position is occupied by only one of the pawn's pieces. For each of the board's 24 positions, 4 inputs to count one's own pieces. It produces as an output the sum of products of each input and its corresponding weight. Palamedes. We should also mention in our presentation Palamedes. Palamedes, formerly known as Tavlingui, is a computer program and the Olympiads of Computers Game champion in Backgammon in 2011. It was created by researchers in University of Macedonia and it uses reinforcement learning. It is a freeware program that can play Greek backgammon variants, Plakoto, Portes and Fevga. Its valuation engine is based on artificial neural networks that were trained using reinforcement learning. Here we can see a photo from the contest. Palamedes against Benjin Bliss. The score was 2-0. Here we can see the creator of Palamedes winning the first place. It can also be used to analyze positions. The supervisor of the program, Associate Professor John Refanidis, said, "The Palamedes program has played millions of times against itself, and each time he was improving his own performance because of his artificial neural network. This gives the ability to the system to utilize every possible move from each role, predicts the possible next rolls and the next possible opponent's moves, while evaluating the possible moves and chooses the best move each time. The move will give the opportunity to Palamedes to make a successful step to the win." Olympia takes place every year since 1989 and aims to the growth of research at the field of artificial intelligence in games. Palamedes is the first Greek participation at the international contest. So if you think you play well backgammon, you can play against Palamedes. I believe that each dislike at the bottom of this video is because you have played with Palamedes and you maybe you didn't like the results. If you want to download it, it is available from download at the page below. Today we wanted to show the power of artificial intelligence and more specifically the fields of reinforcement learning and artificial neural networks. We showed that artificial intelligence is capable of producing high-performance game-playing programs in backgammon. Artificial intelligence is really very powered, and it's very impressive the way these programs learn by themselves. So if you want, you can download one of these amazing programs and have fun.